Alright guys, so welcome back. We're on piecewise functions. So this first example is kind of incomplete. Like how might I approach a problem such as this, right? So on your test, you will have a question. It's going to say something like, Susan, we're going to take the same stuff and kind of rearrange it. Over the 2 hours of her trip, Susan, we're gonna say Susan travels, she drives, Susan drives for 2 hours. She maintained a speed between 50 miles per hour to 70 miles per hour, right? Does Susan drive 60 miles per hour exactly? Ever, does she? Question mark. If she's going between 50 miles per hour and 70 miles per hour, of course she drives 60 miles per hour exactly. At some point, it might be at a specific point in time, or it might be for a couple of minutes or more. We don't really have enough information to find it out, but we can say because her range is between 50 and 70, she has to hit 60 at some point. When she's speeding up, she has to hit 60 at some point. If she's slowing down, she has to hit 60 at some point within that drive. So yes, and you can explain similarly. So what we want to do is look at piecewise functions. I don't think that's a good question or a good example for a word problem for this particular type of function. But the piecewise function, we're going to look at it. You can use Desmos to look at it. And what it looks like, I have already screenshot it and brought it over from Desmos here. And you'll see me at one point actually do this with the Desmos graphing calculator. So just for right now, as we recall, this is talking about as x right here, approaches to the right, approaches from the right, which means I'm going back this way. I'm approaching, what number am I approaching? I'm approaching 1. So 1. Remember, the positive side of 1 and the negative side, coming from the left is negative, coming from the right is positive. So as I approach 1 from the right, I'm going to hit a height of, looks like, -3. As I approach 1 from the left, I'm going to hit a height of, looks like, 2. Now, it says as x approaches infinity, where is it going? It's going to 3. It never goes past 3. This height never goes past 3. As it keeps going to the right, it never goes past 3. Height never goes. Now, as it goes to negative infinity, it's going down as well. So it's going to negative infinity. As it goes to 1 as a whole, because there's a break there, that limit does not exist. Does not exist. Let's look at number next. It says as x goes to 2 from the right, and then as x goes to 2 from the left, and as x goes to 2. So let's look at what that looks like graphically, right? So let's go to Desmos and let's let's type these in. I'm gonna bring up my Desmos here. Let's type these in real quick and look at how we might go about doing that. So let me go grab this. Took me a minute, guys. Sorry about that. All right, so let's minimize and bring this over. So let's look at what that looks like as an equation. So as you can see, I got some stuff going on here. So on the left, I've written my equation as negative x plus 3, but how do I represent that inequality, that it stops somewhere? You do it inside of curly brackets, right? And then I go and look at line 3, I have 2x minus 3, and I have the inequality inside of curly brackets. Once I'm done, I have this object. So I'm going to screenshot. I'm going to bring it over so I can look at it a little bit more closely. All right? Makes my life easier if I can do that. Oops. I don't want to do that. Control Z. Let's do some color here. All right. So just making sure I didn't like cover the whole thing. So here it looks like it's gonna go hit as it moves to the right. It goes to 1. As it moves to the coming from the left, it goes to a height of 1. And that means since both of these equal 1, then I can say that at 2, in general, it's 1. So you would do the same thing for f of x equals all of this in terms of this piecewise function. And that's a practice problem, so definitely work on that, guys. Same thing here, this page is practice. And you're done. All right, so I will end it right there, and when we reconvene, we'll be looking at finding a value for c that makes the piecewise function continuous. Okay, so have a good day, guys. I'll show you how to do that when you get back, and let's touch base then.